Hi, welcome back to 3.2 Exponential Decay. My apologies, the last video ended just after finishing example B. So we just finished solving those two, and now we're on to example C. So we're just simplifying algebraic expressions that have negative exponents. I can see this one's a little bit complex because I have this algebraic expression right here that's now raised to another exponent. So when I see that, I kind of right away think that I should apply the power rule for exponents. I should do that first. So what that means is I have to take that exponent and I have to multiply it to all the other exponents that are on all the other variables, even including the 1 that's on the 2, because that 2 is actually raised to the exponent 1. So it's kind of like distributing that -3 into the bracket. So we're multiplying it with all the other exponents. So we would have 2 times 1 to the -3. So I'm just going to kind of clearly spell all this out here. So 2 to the -3. Then my u has an exponent 2, and that's multiplied by the -3. And then the v, that one's -2 times -3. So we'll have to evaluate all of that. So 1 times -3 is -3. 2 times -3 is -6. And -2 times -3 is +6. So the next thing I want to do is probably use my negative exponent rule. Negative exponent rule. So the 2 to the -3, I should write that as 1 over 2 to the +3. Rewrite that with a positive exponent. And then I also have u to the -6. I'll leave that up here. And then we have v to the +6. All right, so we do have, because of that negative exponent on u, I should actually rewrite that as 1 over u to the 6. So we actually have 1 over 8, because 2 cubed is 8. And then I have times, I could write it like this, 1 over 8 times 1 over u to the 6. So I apply the exponent rule again, the negative exponent rule, rewrite u to the -6 as u to the +6. And then I have v to the 6 again over here. Okay. If you want, you can think of this out over 1 to kind of help you out. And then in my last line, I just kind of multiply everything. So 1 times 1 times v6, so that'll be v6. And then on the bottom, 8 times u to the 6 is just 8u6. So that's it. That's fully simplified there. All right, so now we're going to move on to our next rule. What happens when we have a fractional base with a negative exponent? So far we just learned what happens when we have a base to a negative exponent. We just rewrite it. We write it in the denominator with a positive exponent. But now what happens when we have a fraction inside? So like this here. Okay. All right, so the rule is that we just flip the base and then we can rewrite it with a positive exponent. That's all we have to do. Okay, there's a couple restrictions. A or B cannot be 0, because then we would be dividing by 0. That would be undefined. And the exponent just needs to be a natural number like 1, 2, 3, or 4. All right, we'll go ahead and do some examples of this. So these are actually quite easy to do once you can remember the rule. So the rule states if you have a fraction raised to a negative exponent, then you can flip the fraction and then rewrite it with a positive exponent. So 1 over 3, we would have to flip that and then write it with a positive exponent. So as far as the rules go, you can just say write as a positive exponent. And obviously 3 over 1 raised to the exponent 1, well, that's just going to be 3. So another proof for this rule and why it works is if I tackled this the old way, how we were doing these, so if you said anything raised to a negative exponent, you put it in the denominator. So the old way of doing this, we might have done it like this. We might have wrote it as 1 over and then write the 1 over 3 inside with a positive exponent, right? That's what we said to do before. You can move it into the denominator and write it as a positive exponent. Well, 1 divided by a third, this means 1 divided by 1 over 3. Well, that actually means we need to flip and multiply, and we also get 3. So we can see that this rule of flipping the fraction around and then rewriting as a positive exponent actually works. Okay, it might actually make you a little bit easier to remember the rule too. So, okay, now this example here. So what I would do with this one is I would just flip it. Okay, so do the reciprocal. You can write it as negative 8 over 27, and then to the positive exponent too. All right, so negative 8 over 27 times negative 8 over 27, that's going to equal 64 over 27 squared is 729. Okay. What you could also do is you could think of it as negative 8 squared over 27 squared. So square the top, square the bottom. And when the negative is written like this, if you don't know whether you should put it in the numerator or denominator, I would just put it up in the numerator like I did up here. So that works out to the same value as 64 over 729. Okay, that's actually it for 3.2. Hope you guys found these videos helpful, and I'll see you later.